So ngayon guys, no, we're already done with the construction estimate na part. We will now tackle the planning na part. For the planning, we have the PERT and the CPM. So ano ba sila? So si PERT, ito yung Project Evaluation and Review Technique, and the CPM, ito yung Critical Path Method. So ano ba pinagkaiba ng dalawa? Let's start with their orientation. Si PERT guys, it is event-oriented, while si CPM is activity-oriented. So example ng activity guys na concrete pouring, or pwede din rebar, fabrication, no? Magpabricate ka ng bakal na magbebending ka. Event on the other hand, ito yung project start, project finish, project milestone, that's no event. So technically, no, sa ating topic na to, when you say activity, it is a something that will consume resources and time. For example, concrete pouring and rebar fabrication, di ba? It will consume resources and time. Event on the other hand, it is something that will happen pero it won't consume resources and time. For example, pag start ng project, may na-consume ba ng resources dyan? Wala man, di ba? Start lang. After completing the task, you have your project milestone. So that's the event. Technically guys, no, sa diagram pa lang, you will know if it is a PERT or if it is a CPM. Kasi guys, meron tayong node and then arrow sa ating PERT CPM, no. Si CPM, it is node oriented. Kasi guys, no, per activity, isang node may activity tayo. Second activity. Si PERT naman is event oriented, no. Ito yung event A, then ito yung activity natin. Then event B, another activity, event C, ganun po siya. Bali yung activity po natin sa PERT, it is on the arrow. Si CPM naman, yung activity natin, it is on the nodes. Okay, dyan pa lang no, ma-visualize mo na yung difference. And then pagdating sa modeling natin, yung algorithm nila, si PERT, this is probabilistic, while CPM deterministic. So what does it mean? Si PERT is, no, we don't assume no, in the algorithm na totally yung value na yan mangyayari talaga siya 100%. Kasi it is the word sa probabilistic, no, may chance na hindi yan mangyari. Well, CPM on the other hand, it is deterministic. No? Anong ginawa natin sa algorithm or sa flow ng ating activities? We assume that it will be followed or it will happen in actual. So you might think, no sir, if that's the case, yung CPM pala, hindi siya maganda gamitin sir. Ganun, kasi in actual construction, hindi naman talaga nasusunod yung ating project schedule, diba, yung ating plan. For example guys, when we analyze our trusses, no, diba? Diba, ang assumption sa pag-analyze ng truss guys is we have a two-force member. When you say two-force member, yung ating member ng truss will only carry axial load. And it will only happen if maglo-loading tayo sa may joints natin or sa nodes natin, no. Ngayon, in reality, naglo-load lang ba tayo sa ating nodes in actual? Actually no, hindi, kasi most of the cases, no, yung purlins natin hindi naman sumasakto sa ating nodes. So pag nasa gitna yan ng member, ano mangyayari? It will induce bending moment. So therefore, yung ginamit mong analysis, no, for the truss, hindi siya nasunod sa actual. But does it mean na itong analysis of truss walang kwenta yan dahil hindi nasunod sa actual? Answer is no. Kasi guys, by using analysis ng truss, no, yung two-force member lang, napadali natin yung analysis process, no. Naging mas easy yung ating computation. And then the result naman, hindi naman siya ganun kalayo if we consider the bending moment. It is an acceptable process. Same idea sa ating CPM, deterministic siya, though hindi siya nangyayari sa actual, but we can use it as our reference for our planning. With regards sa estimate, no, CPM, one-time estimate lang tayo, no, isang oras lang tayo meron. Si PERT, we have three-time estimates. Anong time yun, sir? For example, you have activity 1 sa ating node sa ating CPM. Okay? Sabihin natin, activity 1 will take 1 week. Activity 2, let's say, no, 3 weeks. Okay? Bali, per activity, we only have one time duration to finish that. While in PERT na process, no, in one activity, we have that long time duration. We have first is the optimistic time, no? Optimistic with the word itself, no? This is wishful thinking, meaning we assume that the project will finish the earliest time, okay? Then we have the most likely time, na ito yung tingin natin na most likely mangyayari. And then we have the pessimistic time. So ito yung minamalas talaga tayo sobra-sobra ng maraming delay. So meron tayong tatlong oras for the PERT na process. Regarding for the kung saan siya suitable, no? Well, of course, in PERT, it is high precision time estimate. Alam mo kasi tatlong data yan compared to your CPM na tag-iisa lang per activity. And then si CPM, it is intended, no, for repetitive job activities. For example, yung ating construction industry, no? Kasi, for example, gawa ka bahay. Ano ba ginagawa natin? Well, ulit lang. Excavation, gawa ka footing, then formworks ka, column, and after column beam, slab, then ulit na. Okay, so that is CPM is very useful sa construction. Well, si PERT, guys, it is created most likely, no, or most inclined to research and development projects. But it doesn't mean na hindi mo magagamit yung PERT natin sa construction. You can also use this one. Yung PERT nga, didiscuss natin ngayon eh. Pero, si PERT lang, medyo matrabaho siya because, no, mas marami kang data na i-process compared to your CPM. Okay? Sige na, let's have our sample problem. Repeating floor-by-floor structural construction activities of the diaphragm shear wall building are shown below. Which of the following gives the duration of the critical path? Recall na yung ating method dito, this is probably critical path method, no? Kasi we are asking the critical path. So discuss later guys na what's the critical path. Right now, remember natin na yung diagram natin dito, meron tayong node at saka arrow. So sa node guys, dito nakalagay yung ating activity. So, pwede tayo gumamit ng circle, or para mas madali guys, no, let's use na lang rectangular shapes sa ating node. Instead of circle, let's use rectangle. Kasi pag mag-circle ka, hindi naman perfect circle yung nadodraw natin, diba? So medyo pangit tignan, no? So let's have rectangle na lang. On the upper left, you will write here the activity meron ka. It could be activity A, B, C, D, and so on, okay? Sa baba niyan, you will write here the duration of that activity. For example, if you put here activity A, duration will be 7 weeks. And then sa gitna guys, you will write here the early start, then next dyan is yung early finish. Then sa baba, you'll have your late start, then you have your late finish. Ang gawin natin ngayon, no? Let's draw muna yung starting event natin, no? Okay, let's have your start. And then, if you look at sa ating table, no? Activity A and activity B, wala silang predecessor, meaning they can start immediately. No? We put our arrow here that signifies the direction of your activity. So let's start with letter A. Activity A, duration is 7 weeks. Activity B, duration is 9 weeks. Then after that, you have activity C. Si activity C guys, no, it is, na predecessor niya is si activity A. So ganito, before makastart si activity C, dapat matapos muna si activity A. Ang activity C, may duration siyang 12 weeks. After that, you have activity D. Si activity D naman guys, no, kailangan muna matapos yung activity A and activity B, no, before siya magsimula. So ito si activity D with duration 8 weeks. Then after that, you have activity E. Si activity E naman, ayusin ko lang, yan. Si activity E naman, may duration siyang 9 weeks and then you need matapos muna si activity D before siya makasimula. And after that, we have activity F. Si activity F naman, kailangan muna matapos si activity E and activity C. And meron siyang duration na 6 weeks. And lastly, we have activity G. So patapusin muna daw si activity E before magsimula si activity G with duration 5 weeks. And after that, wala na continuation sa ating activity, so malamang it will go to your end. Patapusan natin. So yun lang po, no, you have the start, you have the end, yan po yung ating diagram, no. Ngayon, ano man tong early start, ano man tong early finish? So let me explain it, no. So si early start guys, no, by the word itself, ito yung pinaka-early natin na pwedeng simulan yung project, yung activity na yan, I mean, okay? So, ang ginagawa natin dito, we always put the largest predecessor, okay? So, ano bang largest predecessor, sir? Ano man yan? O, sige, na-explain ko. So, for example, activity A and B, what is their early start? So, since silang dalawa, wala silang predecessor, they can start immediately. So, the early start would be 0. They can start immediately. Okay? Ano naman ang kanilang early finish? So, si early finish naman guys, no, you can get this by getting your early start, then dagdag mo yung duration. Okay? So, early start ni A is 0, duration niya is 7, you will have here 7 na early finish. For activity B, you have 0 plus 9, you will have 9. Okay? Sige na, proceed tayo. Let's go to activity C. Sa activity C, anong predecessor niya? Diba? Only si activity A. So, ano yung early finish, no? Ano yung early finish na kanyang predecessor, no? Largest predecessor na early finish, no? Yan po yung early start mo. So, for activity C, since si A lang yung predecessor niya, you put here 7. Then, to get early finish ni C, that would be 7, early start niya, plus duration na 12, and you will get here 19. Now, proceed tayo sa activity D. Sa activity D, meron siyang dalawang predecessor, si A at saka si B. Ano sabi natin, pag ano ipapasok sa early start, you will input the largest predecessor. Okay? So, ang largest predecessor natin, no? Di ba, you have here 7, you have here 9. So, sino largest dyan? So, you will use the 9, so siya mas malaki, di ba? So, you put here 9 as your early start. Ngayon, sir, bakit kaya ganyan? Do I have to memorize this, sir? Pwede bang may way to absorb this na walang memorization? Actually, no pwede, kasi you have in 9 here for the reason na hindi pwedeng makastart si D pag hindi pa tapos si B. Kasi diba yung predecessor niya, ito yung requirement niya. Predecessor niya si A and B, dapat matapos muna yung dalawa before makastart sa activity D. So hindi siya pwedeng mag-early start ng 7. Kasi pag 7 nilagay mo sa early start, hindi pa tapos si B, no, hindi ka pa makasimula. Therefore, the early start for you would be the last activity na matapos sa predecessor. And that's when we use largest predecessor na early finish. I hope na gets yun. So for the early finish for this activity, that would be 9 plus 8, you'll have 17. Let's go to activity E. Isa lang predecessor niya, you have your 17. 17 plus 9, you have 26. And then sa activity G, kasi F muna, si F, dalawang predecessor, you have 19, you have 26. So let's use 26 kasi largest yan. And 26 plus 6, you'll have 32. Ito naman activity G, you have 26, so mag-isa lang na predecessor. And then you have 26 plus 5, you have 31. So from here, no, makikita mo actually, no, sa early finish, dyan mo makikita yung duration natin. So ang duration natin, it will take 32 weeks, no, yung pinakamatagal. Okay? So of course, no, you will get the largest values for your project duration. Kasi guys, no, if you use 31, no, and then ito activity, if hindi pa pala tapos, of course, no, it doesn't make sense. You will use the largest duration, the largest value for your duration of the project. Okay, that's why you have 32 weeks. Ngayon, we already have the early start and early finish. Let's input naman yung ating late finish and late start. So for the late finish, guys, no, you will input here the smallest successor. So technically, guys, no, baliktad lang yung gagawin natin sa late finish and late start. No? Sa early finish, early start, ang direction natin dyan pag ganito, okay, let me color this lang properly. Okay, ito yung direction ng mga early natin, early start, early finish. Ito naman yung direction ng late start, late finish. Okay, magsisimula ka sa pinaka dulo, no? So duration mo 32, what would be your late finish? Okay, let's start with activity F. Ating late start, si 32 yun. Bali, ano yung project duration mo? Yan mismo isulat mo agad sa dulo ng mga activities, no, as your late finish. And to get your late start, ang gagawin mo lang is you obtain your late finish, subtractan mo lang ng duration. Technically, kabaliktaran lang siya sa ating early start, early finish, okay? So if you do that, 32 minus 6, you will have here 26, di ba? Sa activity G, that's 32 minus 5, you will get 27. Activity E natin, no? Ano man yung ating late finish? So, di ba meron siyang dalawang successor? Sa activity F and then activity G. So, di ba we will input the smallest successor na late start? So, sino mas maliit sa dalawa? Mas maliit 26. So, we will use 26 here. And then 26 minus 9, you'll have 17. And after that, proceed to activity D. Ano yung smallest successor na late start niya? Successor ni D, si E man. So, ang smallest niyan, 17. Siya mag-isa. So, 17 to automatic. 17 minus 8, you will get here 9. Activity C, okay, isang successor lang din meron siya. You'll have here 26. And after that, punta tayo activity B. Yung successor niya si D lang. And then the value of that is meron kang 9 na late start. And then 9 minus 9, you have 0. For activity A, okay, dalawa successor niya si C at saka si D. Okay, ano yung smallest na late start ng dalawa? So you will use 9 here. And 9 minus 7, you'll have 2. So there you go guys, kung nakuha mo na yung late start, late finish. So ano ibig sabihin ng late start, late finish na yan? Tignan nyo guys, tignan nyo. Di ba yung activity D natin, looking at activity A, B, and D, si activity D can only start if tapos na si A at saka si B. Ayan. If you notice, si activity B, wala siyang, okay, I mean, equal ang kanyang late start, saka late finish, early start, early finish, and late start, late finish. So anong ibig sabihin nun? Pag equal itong mga numbers na to, these are what we call the critical activities. So anong ibig sabihin pag critical activities? Meaning yung activities na yan, hindi yan pwede ma-delay kasi critical yan. So anong ibig sabihin nun? If that is critical, meaning pag ma-delay ka lang isang activity dyan sa critical activities meron ka, delay na yung whole project. Kaya tinawag siyang critical, ito yung binabantayan mo para hindi ma-delay yung project. Other activities na hindi critical, o hindi along the critical path, pwede sila ma-delay. Pero for a certain amount only, hindi rin pwede sobrang delay, no, kasi madama yung iba. For example, I'll give example. Activity A will take 7 weeks. Activity B will take 9 weeks. And then critical path man si B at si D, no? Si D, magsisimula siya early start niya 9 weeks, no? Para pusin muna si B, no? Therefore, since 7 weeks lang si A, okay, may extra 2 weeks tayo na pwede tayong mag-chill. Therefore, meron siyang late start na 2 weeks. Okay, kahit mag-late start, mag-start ka ng 2 weeks na late, hindi pa madidelay yung project. Okay, yun yung purpose ng late start na yan, at saka late finish. Okay, hope na-gets nyo. Importante actually yan. So, dito guys, no, dito sa mga hindi critical activities, dito ka pwedeng maglaro ng manpower mo or ng equipment mo. Kasi for example, sa isang project, hindi naman palagi no perfect attendance yung tao, di ba? May mga emergency yan sila. May times na medyo kukulangin talaga tao mo sa site. So if that's the case, and then if kaya naman ng mga skill ng tao mo, you have to prioritize, you have to allocate those manpower dito sa critical activities. No, hayaan mo muna itong non-critical para hindi po ma-delay yung project mo. Yun yung purpose ng CPM na yan. And then, the path na kung saan dumaan yung critical path natin, mga critical activities I mean, anong dulo dyan? That would be your critical path duration, no? So, in this problem, yung dulo natin, that is 32. So, technically, critical path, that is your project duration, ang pinakamatagal na duration ng path na magawa natin. So, for number 10, your answer would be letter C, 32 weeks. So, sige na, proceed tayo next item. What is the longest delay that the activity C can have without causing delay in the overall structural floor construction? Actually, guys, yung diagram na meron tayo dito, this is about the structural construction activities, no, ng isang diaphragm shear wall building. That delay, guys, no, tinatanong sa problem na to, that is actually your slack. To get your slack again, ang gawin mo lang is you obtain the difference of this or this one. That would be 14 minus 7, or you can also have 26 minus 19. It will give you the same answer, okay? This will give you 7 days of slack. Now for last situation, proceed naman tayo sa ating PERT na topic, no? So situation number 5. For the following PERT network diagram given below, time duration is in weeks. Number 12, determine the expected project length. So first of all, let's draw muna yung ating diagram. Question sa atin is, ano daw yung expected project length? So medyo madugo ito isipin, no? Kasi if you check the given, meron tayong tatlong time. Optimistic time, most likely time, and pessimistic time. So how do we obtain the time na gagamitin natin per activity? If meron kang maraming data, di ba, for us to get the probable value na gagamitin natin, di ba, we do averaging. So most of the time ginagawa natin is we just do it arithmetically, no? So we put weight equally to everything. So kung meron ng tatlong time, add yung tatlo divided by 3. Okay, yan yung arithmetic method. Pero guys, in a PERT network, pag walang sinabi yung problem, we will average our effective time, no? Effective time yung tawag dyan, no? Sa magiging average ng tatlo na yan. Pero pag average natin, we will be using yung prismoidal na concept. So isang weight sa ating optimistic time, apat na weight sa ating most likely time, then we have another one weight sa ating pessimistic time over 6. Bali, we give emphasis sa may gitna, no? Mas malaki yung timbang niya kasi it is the most likely time. So let's get that value, no? The effective time for each activity meron tayo. Para mapadali yung ating pag-solve, guys, no? Let's input sa calcio variable A plus 4B plus C over 6. Then pares lang tayo ng solve, no? Okay, input the value of A for activity 1, 2, you have 1. Then most likely time, you have 1. And then pessimistic time, you have 7. You will get here 2. Okay, next activity tayo. So ito yung effective time natin per activity. So yan na ngayon yung pwede mong gamitin, no, to get your expected project length. So let's input the effective time duration per activity. So to find your expected project length, hanapin mo po yung pinakamatagal na past duration. So anong duration na magawa natin dyan? We can write 1, 2, 5, 6. Okay, we can also do 1, 3, 5, 6. And we can also do 1, 4, 6 duration. So ito yung first duration natin, no, yan. That one. Ito yung pangalawa. Ito yung pangatlo. So sige, no, let's add now the duration na madadaanan natin. So activity 1, 2, 5, 6, no? You'll have here 2 plus 1 plus 7. This will give you what? This is 10 weeks. Activity 1, 3, you have 4 weeks, then 6 weeks, then 7 weeks. Okay, add mo yan, you'll have 17 weeks. Then lastly, you have activity 1, 4, 6, you have 3 weeks and 5 weeks. You have 8 weeks duration dyan. So for this problem, guys, no, ang longest time na duration natin, that is 17 weeks. Okay, highlight ko. So this would become our project length, no, yung ating project duration. That would be letter B. Okay, 17 weeks. For our next item, determine the standard deviation of the project length. So before we have the standard deviation, no, that's sigma, diba, standard deviation. Let's discuss first variance. Diba we know variance that is just the square of standard deviation. So technically, guys, ang gagawin natin dito, we'll be getting the variance for each activity. Pagdating sa first na topic, yung creator po nito, meron po silang ginawang approximation na mas madaling way to get your variance. Again, this is applicable for the PERT lang na network, no? So we have here, ang ginagawa nila is, they get the difference ng pessimistic time at optimistic time, divide this by 6, square nila. And that will be the variance per activity. Okay, sige, let's solve this one. And same thing ginawa sa calculator, let's put muna yung ating data, no, ay yung ating variable a and b over 6 square. By doing this, guys, no, by having a variable na a and b, you can set it as your TP and TO so that no, kung ulit yung process, press calc lang, no, input a and b para mabilis. Okay? So kung gawa mo yan, press calc, input mo yung for activity 1, 2, yung pessimistic times 7, optimistic times 1. Okay, you will get here 1. So right now, we have the variance per activity. Ngayon, how do we get the standard deviation of the project length? Kukunin mo ngayon yung variance ng ating project length. Meaning, i-add mo lang yung variance which belongs to the project length. Kasi yung longest time, that will be your project length. So anong duration mo yan? You have, anong activities mo yan? You have activity 1, 3, activity 3, 5, and activity 5, 6. So ito po yung gagamitin mo na variance na, yung tatlo activities na, you will use that variance to get the project length and standard deviation. Okay? So first, kuha ko muna variance ng project length. That would be variance ng 1, 3, you have there 1. And then variance ng 3, 5, you have there 4. And lastly, variance ng 5, 6, you have there another 4. So a total of 9 weeks. That's your variance. But we are asking for standard deviation. So yung variance, that would be square root of 9. And this will give us 3 weeks. So this would be your answer for number 13. No? Ito yung ating standard deviation. For our last item, no, tanong po sa atin dito, determine the probability that the project will be completed on schedule if the scheduled completion time is 20 weeks. So you notice, this problem, it is asking for probability. So sir, bakit yung probability yung topic natin sa construction? And again, no, this is PERT, no, na topic. So si PERT, this is the probabilistic na model, no. So it can give you a probability or chance na compute mo yan kung when matapos yung project mo. So technically, we'll be utilizing the normal curve, no. Diba sa normal curve, yung gitna mo, this would be your expectation or your mean, no. So technically, yung expectation natin, mu, that is actually your 17 weeks, okay? That is your na-solve na project duration kanina, no, sa first item natin. Ngayon, ang tanong man sa atin, ano yung probability na matapos siya? No, the scheduled completion time is 20 weeks. So we need to get the z-score. Okay, diba? Along the horizontal natin, no, diba z-score yan? No? We need to know the z-score ng ating 20th week, no? 20 weeks na duration. And how do we get z-score? Diba z-score, masolve natin yan by getting the data natin, which is 20 weeks, minus your expectation over your standard deviation. So you have here 20 minus 17 over standard deviation na 3. 20 minus 17, ano man yan? You have here 3 over 3, you have 1. Okay, you have z-score of 1. And again, no, sa ating normal curve, if you recall, this is 0 yan, no? Ang z-score natin dyan, ang z-score natin 0 yan, then positive z-score pa right, no, negative z-score pa left. Okay? So if you have 1, nandito yung ating z-score na 1, no? So if you want to get the probability na matapos siya, completion time is 20 weeks, first of all, let's understand, ano yung 20 weeks na completion time? Is it necessarily on the 20th week siya matapos? If matapos ako 1 week before, pasok na ako sa schedule ng 20 weeks. Of course, no. Kasi when you say your completion time is this amount, if matapos ka ng early, you still completed within that duration ng project, okay? So if matapos ng early, mas better yun. Therefore, ang probability na kukunin po natin is yung probability na makatapos tayo before or on 20th week. With, ang 20th week, that is my z-score na 1. So ito yung nasolve natin kanina na this one here. Okay? So to get that area, if we understand yung ating normal distribution, no, ang gagawin lang natin is we will get the area left nitong z-score na 1, di ba? And okay, makukuha mo nila yan ng mabilis. This is our calculator na function. No? So ang gagawin mo lang, guys, no, sa calculator, punta ka lang ng mode 3. Okay? Then wag ka lang mag-press dyan, okay? So i-cancel mo lang after. Ang purpose natin is makalabas natin yung apps function sa mode 3. So you press apps button, then you click, or you press number 7, that's distribution. So if you recall, no, yung number 1 dyan, yung P, yung kukunin yung area dyan is pa-left ng z-score mo. Yung R naman, that is pa-right ng z-score mo. Okay? So let's use number 1, no, yung P. So P natin, yung input here, no? You input your z-score, which is C1, di ba? And it will give you the area ng ating diagram, ng ating normal curve, pa-left ng ating z-score na 1. And that is 84.134%. And that area actually, no, if you recall sa ating normal distribution topic, that area constitute to your probability. So meaning, we have an 84.134% chance na matapos yung project within 20 weeks. Okay, so diba amazing is, no? So we're able to predict the probability na when matapos yung project. Pero again, no, ang effectivity nito will depend on the reliability of your data na meron ka dito. Okay, yan mo yung hirap na part is, no? The computation is very procedural, no? Ang sa construction industry, ang mahirap na talaga i-secure is yung durations natin per activity. So anyway, for number 14, our answer would be letter B, 84.134%. For our next problem, we have here an objectives na lumabas doon sa November 2021. This is still about the construction planning or the project management planning, that is your PERT and the CPM. Sige, simulan natin. First item. Of all paths through the network, the critical path has the letter A, maximum actual time, letter B, minimum expected time, letter C, minimum actual time, and letter D, maximum expected time. So if you recall last time, yung previous na situation, di ba, ang critical path, yan yung longest duration na path. So of course, hindi tayo sasagot ng minimum, no? So it is either A, no, or letter D, kasi yung may maximum na value, maximum time. But ang issue na lang dito is, anong time ba yan? Is it the actual time, or is it the expected time? Well, the answer for this is, isasagot natin letter D. Kasi guys, when we create the critical path natin, that is still expectation, no? Nagpaplano ka pa lang, hindi pa yan nangyari in actual. Kaya we call it maximum expected time. Which of the following satisfy the requirements for estimating the expected activity times in a PERT network? Number 1, make use of 3 estimates. Number 2, puts the greatest weight on the most likely time estimate. And number 3 is motivated by beta distribution. So if you recall kanina, di ba yung ating problem, kung PERT network, sa isang activity, meron kang tatlong time durations. Di ba, we have the optimistic time, we have the most probable time, and then lastly, we have the pessimistic time. Or sa ating notation sa right side, ang ginamit naman dyan is A for the optimistic time, M for the most probable time, and then pessimistic time, gumamit siya ng B. So diba, when we use PERT network, sa isang activity, we have tatlong time duration. Now, tama ba yung sinabi sa statement number 1? So diba sinabi dyan, make use of 3 estimates. Ang 3 estimates na tukoy dito, that is your time. Diba? That is your time, 3 estimate. So therefore, correct itong first condition. Now, proceed tayo pangalawa. Puts the greatest weight on the most likely time estimate. So kanina, when we solve the expected time, diba, ang ginawang solution is para siyang prismoidal. We put 1 weight sa ating optimistic time, 4 na weight sa most probable time, and then isang weight ulit sa pessimistic time over 6. Or dyan sa ating module, A plus 4M plus D over 6. Kasi again, nasa module natin, optimistic time is A, pessimistic time is B, most probable time is M. So, of course, yung second statement, that is also correct. So, ang point ko lang dito guys is, you can only answer yung problem dun sa board, no, if naiintindihan natin paano ba sinusolve yung ating PERT network. Okay, kaya nag-solve tayo kanina before tayo nag-tackle right now sa mga past board na objective regarding this topic. Okay, na-proceed tayo sa third. Ang sinabi is motivated by beta distribution. So, itong formula lang ito guys, this one, yung nasa baba, that one, and itong pag-solve the standard deviation na medyo weird yung formula. Kasi we know in statistics, iba yung formula doon, di ba? Yung normal na sa standard deviation. Dito nag-iba konti kasi nga, these methods here intended tong gamitin under beta distribution. Pag nagpo-PERT tayo guys, ang distribution ng ating data, okay, to get the expected time, naka-beta distribution po yan. Kaya therefore, yung third natin na value, this is correct also. Pero guys, kung sa board exam tayo, for example, hindi ka sure sa third value, no, question mark yan, hindi mo yan sure. Pero kung naintindihan mo siya paano i-solve, di ba nakasolve tayo ng expected time using the estimate, so sure ka sa number 1, correct yun. Sure ka rin sa number 2, kasi ang solution mo dyan, kasi nga, nag-prismoidal tayo, di ba? We put more weight sa most likely time. So therefore, sasagot mo, dapat may 1 and 2, tingin sa choices. May 1 only, 3 only, 2 only, di meron kang all of the above. Kasi sakto yung 1 and 2, wala nang ibang choice, kundi letter D. Halata is na kahit hindi ka sure sa number 3, halata na yung sagot is all of the above. So pwede mo yung gawin sa board exam, no? Para at least, kahit hindi ka sure sa ibang statement, makakasagot ka pa rin. And that's it, no, for that past board, sagot is all of the above. Which of the following is the calculation of the probability that the critical path will be completed by time T? So diba kanina nag-solve tayo ng probability when matatapos yung project within that duration. Okay, so kanina diba, balikan natin, nakasolve tayo ng value, we have the 84%, diba? Now, paano natin kinuha yung 84% na yan? No? Just try to remember anong process doon so that makakasagot tayo dito sa ating next problem. So basahin natin. Number 1, assumes that the activity times are statistically independent. Number 2, assumes that the total time of the critical path has approximately beta distribution. Number 3, requires the knowledge of standard deviation for all activities in the network. So let's check na sino yung tamang wordings dyan, sino tamang statement. Let's start with number 3. Requires the knowledge of standard deviation for all activities. Nung nag-solve tayo kanina, kinuha ba natin lahat ng standard deviation sa lahat ng activities? So balikan natin. Ang kinuha natin kanina is hindi standard deviation, kundi yung variance. And in fact, no, hindi mo kailangan i-solve lahat. Diba? Pag i-solve mo itong maybe na the value dito sa variance, that is galing sa activity 1 to 3, ito yon. And then we have 3 to 5, ito naman yan. Then lastly, 5 to 6, ito naman yan. Kaya 1 plus 4 plus 4, that is 9, diba? So ang kinuha mo lang ng variance is within the longest duration of the critical path. Diyan ka lang kumuha ng variance, and yan lang yung kailangan mo to get the probability later. Hindi natin kailangan kunin lahat ng standard deviation or lahat ng variance. So in that sense, yung statement na to, yung pangatlo, this is wrong. Mali po yan. Kasi nga diba, hindi mo kailangan ng knowledge ng standard deviation sa lahat ng activities. So that is wrong. So automatic, no? Maguguho ang mundo ng mga sumagot ng all of the above. So mag-ingat na, pansin ko yan. Pag choices tayo sa board may all of the above, sinasagot ng all of the above, diba? So mag-ingat na lang. Proceed tayo number 2. Assumes that the total time of the critical path has approximately beta distribution. Now, ano nga itong beta distribution? Diba, pag nagbe-beta distribution tayo, we are using this calculation here and the values here. Bali, yung ating expected time, pinuprismoidal natin under beta distribution, then yung ating standard deviation, sinashortcut natin using optimistic time minus pessimistic time minus optimistic time. Diyan ka nag-a-apply ng beta distribution. Now, ang sabi dyan is, yung ating total time ba daw, gumagamit ba daw tayo, total time na ng critical path, gumagamit ba daw tayo ng beta distribution? Well, the answer again is, no. Pag kinukuha mo yung total time, guys, nabalik tayo doon sa ating previous distribution, when we get that time here na 17 weeks divided to 17 weeks, nung kinuha mo to, wala pang beta distribution ginawa. Diyan, nag-add ka lang basic na arithmetic 4 plus 6 plus 7. Walang betang nangyari dyan. Okay, so therefore, yung ating second statement is also wrong. From there, proceed tayo first statement, assumes that the activity times are statistically independent. Yes, that is true. Kasi ang sabi dito sa ating beta distribution, no, the procedure for estimating the expected value of the activity times was motivated by the assumptions that the activity time was a random variable with a particular probability distribution. So when you say random variable noise, it is not dependent on other data, di ba? So that's why this is correct, statically independent tayo. Kaya yung sasagot natin sa password na yan, ang ating answer key for that is 1 only, and that is letter D. The early start time for an activity leaving node C in activity on arrow approach is letter A is the maximum of the earliest finish time for all activities entering node C. B equal to the earliest finish time for the same activity minus its expected activity time. C depends on all the paths leading from start through node C, and letter D all of the above. So do ang ating pinapagamit sa atin dito sa problem is activity on arrow. Ang concept dito is parehas lang din naman when you use activity on nodes. Kasi pinag-uusapan dito is pag-solve ng early start time. Paano ba yung sinasolve? Okay, so tignan natin yung previous equation, kopyahin natin yung data, let's say ito na yan. And check natin paano ba tayo nagsosolve ng ating early start time. Paano nga sinasolve ng early start time? For example, sa node C tayo tumingin sa C. Okay, example lang ito, no? Sa C, okay? So early start time C, di ba makukuha mo yan as your late start, di ba? Again na, early start, that is late start ng ating previous activities. Okay? Now dito, no issue for C, no? Kasi diba, isa lang yung kanyang predecessor, si A lang. So diretso siya, kung 7 yung ating early finish, yung ating early start dito is 7 lang din. Kasi diretso lang yun, siya lang mag-isa na successor or predecessor. Now what if marami? For example, letter D tignan natin. Kung dalawa yung kanyang predecessor, di ba ang ginagamit natin is yung kanyang maximum early finish. Tignan nyo, 7 sana to, this is 9. Ang ginamit natin is 9. Kasi nga di ba, pag nagsosolve ng early start, ang ginagamit natin is the maximum early finish. Therefore, statement letter A is correct. O letter B tayo. Yung early start time daw natin is equal to the early finish time for the same activity minus its expected activity time. So sinabi niya, no, yung ES daw natin for letter B na statement equal daw sa early finish minus activity time. Is this correct nga ba? So diba, pag meron ka ng early start, paano mo kinukuha yung early finish? Diba ginagawa mo, early start plus duration equal to early finish. Sinabi ko, early start plus duration equal to early finish. Now, ang concern natin is this equation ba equal sa equation na to? Well, the answer is yes, diba? Kasi technically ito, nilipat lang sa kabila. Kaya naging ES plus D. Therefore, statement B is also correct. So since A and B is correct na, kahit hindi mo na i-check yung letter C, automatic tayo, all of the above. Kasi diba, kailangan ma-satisfy na correct si A, correct din si B. Diba? Anyway, i-check tayo natin letter C, sabi dyan, depends on all the paths leading from start through node C. Now, yung ating early start ba, yung 7 dito, yung 7 sa letter C, maapektuhan ba siya ng mga activities leading from the start papunta sa kanya? Well, the answer is yes, diba? Kasi 7 mo, nanggaling yan dito, diba? So, ano mga activities from the start papunta doon sa ating goal na activity, yung C na yan, maapektuhan siya. And because of that, third statement is also correct. That's why in this item, ang sagot po natin ay all of the above. The latest finish time LF for an activity entering node H is letter A equals the maximum of the latest start time for all activities leaving node H. B depends on the latest finish time for the project. Letter C equal to the largest start time minus activity time of the same activity. Then letter D, none of the above. So again, kopyahin natin yung previous equation, no, na example sa solution. Ito yun, di ba? Para ma-visualize natin paano ba sinusolve yung ating late finish time. Again, guys, if you are given ng ganito sa board, hindi mo ito masasagutan pag hindi mo alam paano ba sinusolve yung ating early start, early finish, and late start, late finish. Kaya bumalik tayo dito sa ating example kanina sa ating unang situation, di ba? So since wala tayong H dito, sabihin ko lang E yung pag-uusapan natin, ha, si activity E. Now, paano mo natin kunin yung late finish ni activity E? Diba si late finish, ito yun, nasa lower right, diba? So, how do we solve this one? Nung nag-solve ka nito, diba, that is backward pass. Galing tayo sa N, ang duration is 32 weeks, aatras tayo, diba? Atras, okay? Nung pag-atras natin, yung ating early start ng previous or ng successor niya, yan yung magiging late finish ng ating E. Diba, may dalawang successor siya, si F at saka si G. So, sino man yung gagamitin natin na late finish? So, as you can see here, yung late start ito 27, late start is 26, sino ginamit natin? We use 26, diba? Kasi nga, sa late finish, we are using the smallest late start. Okay? So in that sense, no, late finish is smallest late start ng kanyang successor. Therefore, si letter A na statement, this is wrong. Kasi sinabi niya, ang wordings niya dyan is maximum late start, which is wrong, di ba? Kasi late start natin is pinakamaliit yung ginagamit as yung late finish ng ating activity. Proceed tayo. Letter B, depends on the latest finish time for the project. Yung ating 26 ba dito? Si 26 here, this one. Nagdedepende ba siya sa finish time ng ating project? Well, the answer is yes. Di ba ang finish time natin is 32? Galing 32, umatras tayo. Kaya nakuha mo 26 dyan. Therefore, second sentence is correct. Nakadepende yung late finish siya, finish time ng project. The letter C sabi dyan, equal to the late start time minus the activity time of the same activity. So yung ating late finish daw, LF, equal daw siya sa late start minus the duration ng activity. Now, is this correct? Di ba ang mangyayari is, pag meron ka ng late finish, pag meron ka ng yan, how do we get late start? Di ba ginagawa natin is to get late start, that would be late finish minus duration. Yes, ito yung ginagawa, diba? Pag umaatras na tayo, kaya galing 26 na solving 17, we're doing 26 minus 9. Ito yung ginawa natin. Now, is this equation ba equal to this equation? The answer is no, hindi equal. Baliktad yung ating equation. This is LF minus this is LS minus D, which is wrong, di ba? Wrong yung ating third sentence. So in this sense, ang sagot po natin dito is letter B. Of course, hindi tayo sasagot ng none of the above, ha? Kasi nga, meron tayong correct answer. So letter B po yung sasagot natin. The slack for activity G is letter A, late finish minus late start. Letter B, early finish minus early start. Letter C, late start minus early start. And letter D, none of the above. Now, sino man yung mga activities na may slack dito sa ating previous example? Diba may slack? Unang-una, si A, si C, at saka si G. Yung hindi pwedeng magka-slack o yung mga critical activities, yan sila si B, D, E, and F. Halata yung mga critical activities kasi nga parehas yung mga data sa early at sa late values, parehas. Meaning wala silang slack, hindi sila pwedeng mag-delay. Kasi pag nag-delay sila, delay yung buong project. So ito lang yung mga activities yung chinek ko dyan, yan na yung activities na pwedeng magka-slack. Ano ganyan si slack? Yan yung panguyakoy mo sa Bisaya o sa Tagalog, yung pag-chill-chill mo sa trabaho ba? Pwede mong i-delay konti yung trabaho, hindi pa ma-delay yung buong project. Na paano naman isa-solve yung slack na yan? Di ba si slack sinasolve mo yan as the difference, no, ng mga start or the difference ng mga finish. Ikaw bahala saan ka dumaan. So for example, slack ng activity A. Pwede kang mag late start minus early start. Pwede ka ring mag late finish minus early finish. You will get the same answer, diba? For example, you have 2 minus 0, we have 9 minus 7. Still, you will get an answer of parehas 2. Same thing will happen pagdating sa C, pagdating sa G. Ganun tayo nagsosolve ng slack. May isa-isahin natin. Again na, late start minus early start or late finish minus early finish. Unang sinabi dyan, late finish minus late start. Is that correct? The answer is wrong, diba? Hindi yan correct. Kasi letter A. Kasi late finish minus late start, that is duration. Di ba pag nagkuha ka ng difference ng pagganito, di ba? 19 minus 7, that is 12, that is your duration. Okay, so mali yun. So same thing sa letter B, sabi dyan, finish minus start. Again na, pag nag-finish ka minus start, that is always duration. So mali din to. Therefore, to answer the problem, yung nag-satisfy ng ganito or this one, that is letter C. Late start minus early start. Yan po yung isasagot natin kasi parehas yan dito sa shade ko ng green. Okay, that's it. Yan yung ating objective na lumabas no sa ating board exam. Wala pa sa yung first 3 question pa yung lumabas, yung another 3 question, hawig yan na concept sa ating mga lumabas doon sa password.